Well, we really haven't talked that much about tangent, but we should. So let's take a look at this expression right here. We've got the square of tangent of x minus 3, and we're asked to solve it first over the general solution from negative to positive infinity over all real numbers, and then on the closed interval from 0 to 2 pi. And what kind of solution should we get here? Well, our equation, tangent squared x minus 3 is equal to 0, when we set tangent squared x equal to 3, and then we take the square root of both sides. Now remember, when we take the square root of both sides to isolate tangent, as we should, we're going to get two possible solutions right here, positive and negative square roots of 3. So we're actually going to have two solutions that we're going to have to find. The first one is for tangent of x is equal to the positive square root of 3, and for tangent of x is equal to the negative square root of 3. And the thing that we want to point out right here about tangent of x is this. As far as the general solution is concerned, remember that the period for tangent, the natural period for a tangent function, is equal to pi. And that helps us out a lot, because when we take the inverse tangent of radical 3, which is our first quadrant, we're going to get x is equal to pi over 3, right? We're finding the angle whose tangent would be equal to positive square root of 3. But if we're looking for our general solution, what we would want to do is we would say, let's use the period and write that the general solution will be of the form x is equal to pi over 3 plus any multiple of pi. Right? Now, if you think about that, what does that mean? That means numbers like pi over 3, 4 pi over 3, and then 2 pi plus pi over 3, and so on. But our general solution, we write plus pi in because we know that that is the period of the tangent function. If we looked here for our negative root 3, we could say, well, x is equal to the inverse tangent of the negative of the square root of 3. And that happens to fall in quadrant 4. When we take that inverse tangent, we find negative pi over 3 is the natural solution from our inverse tangent function. But to get to the general solution, we have to add multiples of pi. So we're going to say negative pi over 3 plus pi n is a perfectly legitimate general solution. So on the interval from negative pi to positive, from negative infinity to positive infinity, we have pi over 3 plus pi n and negative pi over 3 plus pi n. And that's all well and good. But again, we're looking for all these solutions on the interval from 0 to 2 pi. So let's find out what works when we apply the interval. On this interval, we can't have any values that are negative. So negative pi over 3 is out. However, positive pi over 3, that's in. Right, so that accounts for this first one. If we take negative pi over 3 and add pi, that means we're going to get 2 pi over 3 as a solution. If we take pi over 3 and add pi, we're going to get 4 pi over 3, and that's a solution. And then if we let n equals 2, we get negative pi over 3 plus 2 pi, and we know that's 5 pi over 3. And in fact, what we're saying is that any angle, pi over 3, or reference angle pi over 3 position in the interval from 0 to 2 pi, will give us a value of x whose tangent is equal to 3. And so that's it. That's exactly what we wanted right here, and so we're done.